Hi everyone. So today we're going to be talking about central angles in a circle. So central angles are basically angles that start at the center of the circle. So this angle here would be called a central angle because it starts at the center. Basically we have this rule that whatever the measure of the central angle is, that will also be the measure of the arc. So these are going to be exactly the same when you have a central angle. So the angle measure is equal to the arc measure. Also remember that the total angles or arcs in a circle is always 360 degrees. So we'll keep that in mind when we're solving our problems today. Okay, so we need to find the measure of the arc or central angle indicated. And anything that looks to be like a diameter straight to the center are actually diameters. Alright, so we need the measure of arc, or I'm sorry, angle, WRS. So that's this angle here. We know it's going to be the same as whatever that arc is. So let's fill in what we know. Now, if you see in this problem, the key here is that we have this straight across line through the center, giving us basically a semicircle over here. So we know that these three angles or arcs need to add up to 180. So we can find this little missing one over here by subtracting 180 by 86 and 54. So this little missing guy over here would be 180 minus 86 minus 54, which is 40 degrees. Then remember vertical angles at the beginning of the year, those will be really helpful here as well. So we do have vertical angles here, so those two are going to be the same, meaning that this angle and arc are both 40 degrees. And then we have one more step. So now our orange angle plus that 40 also makes up another semicircle over here, 180. So this missing angle that we need is going to be 180 minus 40, which is 40 degrees. And remember, the arc and the angle, they're the same thing, so we don't have to worry about changing any numbers. Let's see if we have something similar in number 11. Measure of angle GJE. So GJE is in here. So basically we need to find this arc measure. We already know part of it's 55. We need to find this part, and then we can just add 55 to that. So it's going to be 55 plus something. Alright, so it seems like this arc, this angle arc, whatever, same thing, will be the same as this one because they're vertical. And we can find that one because together with those other two, again, we have a semicircle, 180 degrees. So this little piece is going to be 180 minus 60 minus 55. So that little piece is 65 degrees, meaning that this piece over here is also 65. And remember, the part that we want is from here to here. So it's 55 plus 65, which gives us 120 degrees. Okay, the next one we need measure of angle GDI. So GDI is right here. We do know that this one is 90. And you know, this one actually works out really nicely because we have this straight line through the center again. We know that these two together have to make up 180. And if we know part of it is 90, this other part also has to be 90. So not too much work on that one. And then the last one, we need angle TPU. So that's right here. So we do know that that will be the same as this. So if we could find that arc or angle, then that would be helpful for us. However, we have something even easier that I just realized. We have, again, a semicircle. Those three together need to add to 180. We already know two of them, and this missing one is the one that we need. So we just have to do 180 minus 61 minus 60, which I believe is is 19. Let's just double check. Minus 60 minus 61. Oh, 59. Sorry about that. I'm like going crazy here. There we go. So 59 degrees for that one. Okay, next we're going to be talking about inscribed angles. This word inscribed basically means that the angle has its vertex somewhere on the outside of the circle, somewhere on the circumference. So if this is our angle and this is our arc, you simply have to use the rule that the angle is equal to half of the arc. Or you can use the rule that the arc is equal to 2 times the angle. So the arc is twice as big as the angle. Even if you look at it, see that angle compared to that arc? The angle is definitely the smaller one. Alright, so number 14, find the measure of arc or angle indicated. So here we go. We need this little piece here, the arc. So the arc is always twice the angle. And we know the angle is 56, so that means the arc must be 2 times 56, which is 112 degrees. And then the next one, we need to find the angle. So we know the arc. We can still use the same formula. I'm just going to go down here. So the arc is 2 times the angle. And in this case, we know the arc because from here to here, this whole arc is 100 and 140, giving us 240 for the arc. So 240 equals 2 times the angle. Now you can use theta or angle, they both mean angle. So to find the angle, we just have to divide by 2. So our angle should be 120 degrees in that case. Okay, the next one we might have to do a little bit of work first. Again, remember your diameters make up 180 on both sides of the diameter. So here we need to find this arc over here. So we do know that this arc is going to be twice this angle over here, but we still don't know what that angle is. So let's go ahead and see if we can do something. You know what, I actually have a better idea for this one. Now that I'm seeing it, there's probably a faster way to do this. So we do need this arc. But always start with like wherever you see a number. So see how we have 40 there? And it's coming from this angle. If that angle is 40, this arc has to be twice 40. So this arc here has to be 80 degrees within there. And then we know that 80 degrees plus this question mark make up 180. So this question mark simply is going to be 100 degrees. Since it's with 80, yeah, it's with 80 and it makes up 180. So 180 take away the 80 that we have is already 100. So your goal is to really start with wherever you see a number, because that's always going to be the most beneficial for you. Okay, and then number 17, we need to find, again, an angle. So we need this angle in here. And let's see. So always start with where we have numbers and see if we can go from there. So we have this 57 for this angle. So that means that this arc is twice 57 in here. This should be 2 times 57, which is 114 degrees. Now we have this number and this number. We know that those two plus this red one over here have to add to 360 because they make up the full circle, right? From there to there, from there to there, and there to there makes the full circle 360. So this over here is going to be 360, take away 114, take away 136. So that little part is 360 minus 114 minus 136 is 110 degrees for that red part. So we know that this arc is 110, and we need the angle that corresponds with it. And remember that the arc is equal to 2 times the angle. So let's plug in 110 for the arc. That's 2 times the angle. So the angle must be 110 divided by 2, which gives us 55 degrees. for number 17. Of course, if you have any questions, always feel free to just reach out and email me. Okay, and finally we have the equation of a circle. I love this one because it's like pretty fun and easy. So basically, to know the equation of a circle, you just need to know the center, like on the coordinate plane in terms of x, y, and the radius. And then the equation for the circle will be x, like the letter x, don't put any numbers in there, minus x from the center, so I'm going to call it like xc from the center, squared, plus y, don't plug anything in for that, minus y from the center, squared, is equal to the radius squared. And it will make more sense once we see some examples. So if the center is 1, negative 13, you're going to start by setting up your parentheses. So it's x, and it's always minus here, minus, and then we're plugging in this for x in the center, minus 1, squared, plus y minus negative becomes plus 13 squared, equals, now if the radius is 4, you're going to put 4 squared on that side, which is 16. And that's all that you have to do. Very similar in the next one, so center. So it's x minus negative plus 3 squared plus y minus the y value, 10 squared, equals the radius squared, which is 1 squared, which in this case is still 1. Now sometimes you might be asked to go backwards and identify the center and the radius given the equation. So in this case, you're going to take the opposite of this for the x, the opposite of this for the y. So we're going to take the opposite signs. And here you're just going to take the square root, and that will give us the radius. So the center will be the opposite of 12 is negative 12. The opposite of negative 6 is positive 6. And then the radius is the square root of 27, which I really didn't make these come out to be nice numbers. You can honestly, for now, just leave it as square root of 27. In the next problem, I'm going to just change the problem to make it so that way it works out a little nicer. Let's put 81 there, just to show you both ways. Alright, so again, your center is coming from the opposites of these. So the center will be the point. Opposite of positive 11 is negative 11. Opposite of negative 11 is positive 11. And then the radius will be the square root of 81, which in this case is 9. And that's all you really need to do for these problems. So if you have any questions, just reach out and have a wonderful day.